with the evens and questions. But 5.5 is going to take us a couple days, today and tomorrow. Which means that we could technically, if worst comes to worst, we could grade 5.4 tomorrow and then grade 5.5 on Thursday. Or I should say, grade and go over questions of 5.4 tomorrow and grade and go over questions of 5.5 Thursday. We'll see, we'll see. So we're starting in notes, and we're going to cover section 5.5 in notes. You need to take a quiz? Yeah, go ahead. We're starting 5.5 in notes. I'll get far enough so that you guys have a good idea of what's going on. And then we'll go ahead, and if there's time, I know it's chapel day, we'll try to transition to at least checking the evens in 5.4. And then maybe we'll have to go over or save some of the questions till tomorrow as far as, I don't know, we got stuck on the odds or in the evens. You have gotten a correction paper, though, hopefully by this point. If not, there was some breakdown in communication or willingness to help out in your group. You should have a correction paper, and the reason for that is because your 5.1 during period 5 today. I think I have meetings and basketball games literally my day. And period 7 after school. So I'll try to update in red web so you guys can see. However, I didn't want to just put your quiz score in and not get some homeworks in, because otherwise your grade would only be your quiz score, which is really sad. So I'm going to try to get your quiz score and some homeworks in. That way you guys have a little bit of balance there. But as soon as your test comes, the nice thing is you will get a homework check from your homework spiral. You will get a note check, so your portfolio category will have a grade. Your assignments category will have a few grades. But this was only a 10-point quiz. Some of you guys got over 100%, so your grade's going to look awesome. Like it's just going to be off the charts, 120 or something like that for like a day or two. Just kidding, until the test comes in. But just realize, if this test is bad, work hard. Sorry, if this quiz is bad, work hard on the test, because it's going to blow this thing out of the water. Now, if it's good, it does help, right? If it's bad, it does hurt, but it was only 10 points. Does that make sense? The test is 100 points, so just kind of keep perspective when you get it back. Either you're like, oh, I think I got it, I should still do it, but I kind of got it, or like, okay, I kind of got it, like I got some points. It wasn't like I got a 0, but I still, well, I took the quiz. There were still some things that I didn't quite understand. And some of you did make the common mistakes that I tried to warn you about, and you highlighted and you starred. And still, that silly square root one where you plug in and square it and simplify, so many of you killed puppies and all sorts of stuff. So I do need you to do corrections, but it's not because I want to overwhelm you with extra work. It's because you need to figure out how to do it the right way. Does that make sense? Oh dear. Did I lose you all because I talked too long? Maybe. Are corrections going to be useful for you? Long story short. But if I give it to you right now, what's going to happen? And I lose you for the whole class. So I'll get it to you, just not right this second, okay? Okay. Here we go, section 5.5. Real quick, which of these formulas, because we're going to cover a lot of formulas today, but pause. Which ones do you need to memorize? Did you guys write them down? All of them? No, section 5.5. The double angle, the power reducing, and the half angle. There are 5 sections of formulas. You only have to know 3 of them from 5.5. Just like we wrote down on Friday. If you were gone on Friday, it's right here at the very beginning of 5.4 notes as far as which ones you need to study. You need to study the 5.1 formulas, the sum and difference formulas, and double angle, power reducing, and half angle. Now I know some of you are like, that's all of them. No, it's not. Believe me, it's not. By the time we get to the ones that you don't have to memorize, you're going to be so thankful you don't have to memorize anymore, okay? I think it's like product to sum you don't have to memorize, and sum to product you don't have to memorize. Those are the last 2. Oh, that's like chapter 6. Yeah, that's chapter 6. Okay, so you guys have new formulas, and these ones are important to memorize. True? True. So how do we use them? Do you guys remember how in section 5.4, well, I shouldn't say remember. In section 5.4, In the homework, did you see any T-proofs? Yes. Did you see any ones where they gave you like fractions for sine or cosine and you had to make triangles? Yeah. Yes. You should have followed the notes on that. Did you see any ones where there was an equals and you had to go to your unit circle after transforming stuff? Yes. Solving for all the solutions or the solutions between 0 and 2 pi? Okay. Are the directions going to change in this section? No. What changes? You just have some new formulas to use. Like, if you were to see this earlier on in section 5.3 or even 5.4, what would be the dilemma? You see it, you read it. Does it say prove? No, so no T-proof. What does it say? Solve. Oh, so I want x equals. How many? However many. Fit. Good, Jason. However many. But what do we want to do? We want to put it together, but we can't squish them. Yeah, the very mathematical term of squishing. We can't squish them. Lauren's gone. We can't squish them. But now that we have a new formula, maybe mathematically, there's something we can do. Before this new formula, we would have been stuck. Now we can, after we use the formula. But before that, we would have been stuck. Now, we had seen this guy earlier on, but it wasn't a plus, it was a times. And so we were able to set both equal to 0. But with the plus, I don't know. 10 minus 10, or 100 minus 100, or 57 minus 57. There are so many different things that can be 0. I don't know. But as soon as we're able to use the formula, the double angle formula, bless you, blessings, we can pull out the GCF. And Joe already said, hey, the GCF is 2 cosine. 1 plus sine, right? Guys, what do we always do when we have factors equal to 0? Please, a resounding set them equal. Separately, right? Cool. At this point, isn't this kind of like a section 5.3 review? Because it's like, oh, hey, we have some equations and we better go to our unit circle. We have some equations and we better go to our unit circle. If we divide by 2, we have cosine equals 0. Cosine's going to equal 0. Isn't x going to be 0 at pi over 2 and 3 pi over 2? Both of which fit. If you solve for sine of x in the other one, sine of x equals what? -1. When does the y equal -1? Oh, it's the same as... Oh, you don't have to write it twice. It's still the same answer. And we're putting them all together. Okay, fine. Pi over 2 and 3 pi over 2. What was new? Unit circle? Definitely not. Factoring? No. The formula. That's it. That's what all of section 5.5 is. Except there are just lots of new formulas, and some of them are funky and weird. So to that end, we're going to talk about a few more examples. A few more examples even tomorrow. But remember, the only formulas you have to memorize are the double angle, the power reducing, and the half angle. I'll keep on reminding you as we go. Are there great ways of remembering these? Because remember, the sum and difference ones, those are the new formulas in 5.4. Can anyone tell me anything as far as studying those formulas? Okay, Jason just used them over and over again. He has them memorized. Does anybody have any tricks they remember? Joe? Okay, Joe's just going to keep on practicing them and memorizing them. Wait, the sum and difference ones, 5.4, go look at them real quick. Maybe some of you don't know the names. Remember, the formula portion is going to have the names of them.
I also remember what you said about them.
What did I say? Sine stays the same, the sign stays the same. And cosine, the sign flips, changes, right. What else did I say about them? And what does that mean, Jason, co is together? So how does that work? If you have cosine of a plus b, you're going to have a
Cosine of a times cosine b plus sine a times a.
Good. Because cosine is what they're together. It's cosine, sine. Whereas sine's going to be, Tyler's rocking it too. So what's sine going to be, Tyler? if it's sine of a plus b. Yeah. Sine of a, cosine, and then cosine sine. Good. So cosine sine is for cosine, and then sine cosine cosine sine is for sine. And then you remember the signs, same signs change. And then tangent, oh, okay, a little bit harder. But it was a fraction, right? Because tangent is sine over cosine. So what sign, if it's a plus b for tangent, what sign would be on top? Plus, because sine stays the same over cosine minus. And then it's a little bit harder. You have to memorize, oh, it's tangent of A plus tangent of B all over 1 minus tangent of A tangent of B. So are they super easy? No, but there are tricks. The question is, are there tricks here? Not really. I'm coming, hold on. Are there tricks here? Not really, but I can show you a trick for these three. I can tell you right now, on the formula quiz, there is a cosine 2u or 2x or 2 theta, 2 something with 3 equals that all need to be filled in. Jason, go ahead before I show the trick. You're okay? That one, sorry, trick have to memorize. That one, that one's important in calculus too. That one, there is a way, I just don't know if you guys are going to like it. You could technically make this tangent of u plus u. Is u plus u 2u? Didn't we just say that tangent of a plus b is tangent of a plus tangent of a? Tan u plus tan u is 2 tan u, all over 1 minus tan a times tan b, tan u times tan u. Ooh, you could just use the sum and difference. Actually kind of use that in all of them, but it's kind of harder in some of these to get it to simplify down. You could kind of use the sum and difference for all of these. But here's another thing. Hey guys, have you ever seen something with a cosine squared and a sine squared? Haven't we like plugged in for one of them to make stuff combine before? So couldn't we technically plug in for this guy to make him 1 minus cosine squared? And if I, which some of you need to work on your parentheses, don't kill those seals. If I distribute my negative, minus 1 is there, but isn't that plus cosine squared? And what's 1 cosine squared plus 1 cosine squared? What if you want the other one? Sorry, that's a 1. He kind of disappeared. Yeah, do the other one. Instead of getting rid of the sine squared, get rid of the... Couldn't he be 1 minus sine squared? No distributing really necessary. Just a positive 1 in front. 1 minus sine squared minus sine squared. Anyway, there are a couple tricks, but for some of you, you might be like, my brain will be better if I memorize. But what's the struggle? You must memorize. Okay. Find the exact values of. Oh, hey, doesn't this look a lot like section 5.4 right at the beginning? Can you guys go find in section 5.4 the example that we did with fractions? There was like a 3/5 and a 5/12 or 5/13 or 12/13. I don't know, something. What was the hint that we gave ourselves when we saw a trig function equaling a fraction? It was right at the beginning of 5.4, underneath the formulas. Maybe the second example, maybe the first. Those are the formulas, but what was the type of problem? Whenever you see a trig function equaling a fraction and they're asking you for other trig functions, you always have to make a triangle. What am I trying to do? Yeah, practice for the test. See a type of problem and know what direction to go. Isn't it so discouraging when you read a problem and you're like, I don't even know how to start, right? Right? That's rough, yeah. And I don't want that for you on Friday. Now on Friday, you're going to have the sheet of all the formulas from 5.1, 5.4, 5.5, all of them, whether or not you had to memorize them. But you're still going to have to be able to read the directions and know what it's asking you to do. So make a note to yourself, highlight it in section 5.5 and section 5.4 whenever you see a trig function or maybe multiple trig functions equaling a fraction. Make a triangle, but how? Whose sign? can make a triangle by using the sides. And Joe, last week, remember how there wasn't any restrictions? They didn't tell us any clue as to what quadrant, and you were like, wait a minute, it could be second or third? Yeah, this one tells us, which is what the book would do. I gave more details on this example. Matthew's already thinking about it. He's saying fourth quadrant. Do you guys agree? Because 3 pi over 2 is 1.5 to 2. So fourth quadrant, they're telling us the sign is down there. I'm going to make some sort of arbitrary triangle and be like, whatever. I'm going to label for that u. I guess technically u goes all the way around, but whatever. An opposite and a hypotenuse. Come on, cool kids. What's my adjacent?
4.
But it's not written. But it is 4. Why is it 4? How do you know that even though it's not written? Pythagorean theorem, right? 25 minus 9 is 16. C squared minus B squared, square rooted is A. Or 16 plus 9 is 25. Either way. So just because they only give you a little bit of information doesn't mean that you can't figure out the rest. And why am I saying this? How on earth are you supposed to find sine of 2u? I don't know, double that. No. The angle gets doubled, not the ratio. Well, stink, it's impossible. They only told me u. Wait, isn't there a formula? The formula says this is the relationship between u and 2u. If you want the double angle of sine, if you want sine of 2u, what you need is to double what's sine of u and what's cosine of u. I had that. I had sine. Substitute. Remember, sine of u comes out of the game. The trig is gone. His ratio is in. But what do I need? But once you make the triangle, it's like, oh, it's obvious. It's 4/5. What's my final answer? Now pause. Some of you scare me. I still love you, but you scare me. In the 5.1 and 5.2 quiz, there was a place, I'm going to delete this page in just a second, where you had this. And some of you, just because of how you wrote it, you wrote this guy a little bit lower, because I think you were substituting for tangent or something, and there was more to it. But some of you were like, oh, sweet, 1 over cosine. Oh, wait, who's this over? Ah! Were those supposed to cancel? No, not in any way, shape, or form. What were they supposed to do? Multiply. Well, no, it's not plus, but that's good for other problems. It's just times. It's sine squared over cosine. I know, it's silly, but I saw people who got over 100% making this mistake and people that got under 100% making this mistake. Okay, why am I saying that? What do I want you to do right here to the 2? At least think about that he's on top. At least think about, right? At least think about. Just a few of you. The math is what messes you up, the basic math. Just be careful. Put the 2 over the 1. Be sure that you're doing it the right way. -3 and 4 is -12 times 2 is -24. All over 25. 5 times 5. I know it's silly, but a lot of you just made that mistake with trig. Maybe you wouldn't with numbers, but with trig you would. Kiddos, what do you think you're supposed to do for cosine 2u or tangent of 2u? Same thing, except with the other formulas, right? So when, for instance, I'm not going to do the cosine one. Well, I guess I'm a little worried about that one too. Okay, pause. Let me go ahead. Cosine of 2u. You guys have written down 3 different variations. I don't care which one we do. They're all going to end in the same place. Which one do you want? First, second, or third? Third. I heard first also, but third sounds more interesting. 1 minus 2 sine squared u. Why am I worried about this? All you're doing is plugging in. 1 minus 2 squared. What goes on the inside? Which is? The sine of u comes out, his ratio comes in, and that's what's being squared. Substitution. Trig out. In some of your sports, there's like an A team and a B team. And sometimes just a total substitution switch. A team out, B team in. That's what's going on here. The trig's out, ratios are in. Why am I still a little worried? You gotta simplify, right? The multiple choice answers are gonna have one nice little number. So how do you get there? You tell me. How? Square it. Good. PEMDAS. Would you guys have done that? Would you have squared it first? 9 over 25. Why is it 18 over 25? Are you guys doing the math properly? 2 over 1. Why are we multiplying and not subtracting first? Oh, another mistake that happened on the quiz. Killing me. Oops. Redo. If you're wondering what I'm talking about. Square root of. Oh, actually this one was, there were a couple things wrong with this one. But that's all right. If you saw something like 9 minus 16 secant squared, and you did something like negative 7 secant squared, why is that bad? Ah, you can't do, right? No, 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 no. Now, I don't think that was the exact mistake that was made, but it was awfully close to that. There was something where there were two different terms, one had a trig, one didn't. You were like, yay, minus. No. I love you all, but sometimes your math makes me cry. Okay, coming back. So are we doing the subtraction first? No. PEMDAS. Multiplication comes first. So what's 2 over 1 times 9 over 25? Joe is entirely correct, 18 over 25. Come on, cool kids. Some of you dislike common denominators, but you shouldn't. You've been doing them since elementary. What are you going to make the 1? Don't you dare do 17 is the final answer. Some of you would do negative 17 over 25. No, 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 no. Times 25 over 25. 25 minus 18 is? 7. It would have been a negative if you totally illegally did 1 minus 18. Dun, 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 dun. Okay. Are we all right? Why was I freaking out about common denominators? Because of the quiz. What if you see something like cosine of x minus sine of x over cosine of x? Can I do that? Squishy thing. No. Throw them over a 1 and say, you cannot combine. Thou shalt not pass until. There's a meme like that, right? Until what? That's legal. Now, a few of you kind of missed the other part. Over here, there was a sine squared, cosine. Anyway, there was more to this problem than that. But a lot of you are still missing the common denominator link about it being necessary. We did it in notes. We did it in homework. We reviewed it in homework. And I did it again in another section. And I'm doing it again. Are common denominators necessary to put fractions together? Yes. With numbers? Yes. With trig? Yes. Are we okay? Yes. We're trying to be, right? Hang in there. We're trying to be. I know it's a power pack day, but I also graded a lot of quizzes this weekend. What's the one that we didn't do? Tangent. I'm not going to finish the whole thing. But what am I going to do? I'm going to have you guys tell me where you probably would make a mistake. Is that okay? So, in the formula, we need 2 tangent of u, 1 minus tangent squared of u. How did I do that? I did tangent of u plus u in my head. But what do we need to plug into this formula? Tangents ratio. Good. So look to your triangle. Who's tangent? Good. Good. Which ends up being Tyler and Joe. Both got opposite over adjacent, but the numbers, negative 3. Got it. Why am I a little worried? Maybe the squared, maybe the 1 minus, maybe the complex fraction, maybe all of it. How many of you right now are like, even if I got the formula, even if I plugged into it right, I'm a little nervous that I might get it wrong? Okay, good, 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 good. Honesty, at least a third of you. Thanks for being proud, because yeah, it's a hard one to simplify. Not that it should be, but just naturally, it is. So what do you see? You tell me, Joe, shush. Matthew, shush. I just want to hear, what do you see that we should start with? Jason, shush. Yeah, Priscilla.
Can we do like our weird, like, the
We totally can. My Ugandan trick? Yeah. Now, we have a few options. I think before my Ugandan trick, though, we might want to square. Does that make sense? Because if I just see the 4 and I don't see he's really a 16, I could get in trouble. So the first step, you could even leave the 2. That's okay. Or you could reduce, but we can leave the 2. But what do you think I'm going to have you, or I would tell you to do with the 2? Okay, just keep it straight. And then 1 minus, what's this going to become? Okay. Now, Priscilla, now we can do my trick. Because my trick says, look at the little baby denominators. I see a 4, 16. If you were doing like a common denominator, which one would you choose? Yeah. So I'm going to multiply, like we do for common denominators all the time, by a big old 16 over a big old 16. This is a trick that works for complex fractions. A big old 16 over a big old 16. Now we have a few options. You have to be kind of careful on this one. Can anybody tell me a legal way to do the numerator? Denominator's kind of basic, as long as you don't forget distribution. Numerator's a little funny for some of you. Would you go left and then right, or would you go right into left? Well, that's what I do too. Because isn't this just ready to multiply? Okay, so negative 6 over 4 is going to be multiplied by
16.
Over. Whew, good. What happens down here? 16 times 1 is 16, right? Minus, what happens here? 16s cancel and I just get 9. So how do I finish? What happens with my 4 and my 16? Yeah? Negative 24 over. Done.
Wait. Never mind. This actually makes so much more sense than
Well, the formulas are a little bit easier than the last section because it's a lot of just multiplying and plugging in. Well, plus the triangle ones. The triangle ones probably weren't too bad. Okay. Do we need to be careful with the math? Yes. But can you do it? Yes. Joe.
Two values in the tangent, are they always going to be the same? Or are there two values in sine and cosine? This is negative 24 over 25 and 7. Will it always be like, if that was the negative 24 over 7?
What did Joe just see? That Joe.
Pythagorean triple?
Not the Pythagorean triple, but there is a Pythagorean triple.
Like all of the values have the same numbers.
He just said sine of 2u. Wait a minute. It's this guy over that guy. Yes. But this will only be helpful in problems where you had to find this and this to get that. If you were jumping straight to tangent, you probably don't want to go finding the sine and the cosine and then putting them over. But yeah, because of the property of tangent equaling tangent of something equaling sine of something over cosine of something, we could have taken that guy over that guy. The 25s cancel.
Are we gonna need to like do that for every problem, like finding the sine, cosine, and
Help me out, guys. Section 5.4, how many of those were there where you had to plug into all three? Okay. So it's probably about the same, 1 or 2. Yeah. And remember, there are tons of different formulas in section 5.5, so I probably didn't ask you to do it like over and over and over again. I just asked you to do it once or twice.
And if we like, so say you give us this problem and we figured out like what you said, like the 24 over the 7.
Yeah, use the trick. That's totally cool. Just remember on the test, I'm not going to probably give you a long answer. That's tons of plugging in because you can make so many mistakes. I wouldn't want to take off points. It'd probably be a multiple choice asking for just or just. Does that make sense? So then it might not be helpful all the time. But in homework, yeah.
So we wouldn't need to like, show the word for tangent.
Yeah. But not in homework. If you see the trick, you can just divide the 2. That's okay.
What about on the test? Is there going to be a problem similar to
Probably not. That's long answer asking for all of them.
Yeah.
Does that make sense? So there wouldn't be a need or an ability to use the shortcut, I don't think, on the test.
Okay.
Joe?
What if there's like sine 3 of u, and we just use the formula times sine u?
No. But you could do, well, because you're making up a formula. Sine of u does not equal sine of u times.
Sine equals sine of 2u.
For sine is sine squared. That won't. You could make sine of 3u into sine of 2u plus u. Because then you could do A, and you could do B, and you could do the sum and difference formulas of section 5.4. Kiddos, there was another set of formulas that you're supposed to memorize, the power reducing formulas, right? The power reducing formulas. And I know that if I try to totally explain to you why these are useful, it won't make sense. Let's just say, long story short, in the second level of calculus, so not Calc AB, but Calc BC, there are these types of problems in these things that we call integrals, where the kids have to work backwards from formulas that they've worked really hard on in Calculus AB to do these things called antiderivatives. And if there was a squared with a trig, with these trig, it would be impossible for them to do if they didn't use these formulas. So it seems silly to you, but it's a perfectly natural time to introduce them to you. They're super necessary later on. They make an impossible problem possible for calc kids. But for you, it is a trig identity. It is something that is true. It is something that is true. And so we introduce it here because you could play with, work with, practice with the formula itself without having to know all the extra calculus stuff about how it's going to eventually be used. So you're just seeing it now. Do you guys see, though? Is there a study trick with these?
Yes.
Oh, yeah. Right? Look at the sine and cosine. Now, it's a little rough. Sine has a minus and cosine has a plus. It doesn't necessarily correspond to our trick. That's a little rough. Which one's which? But if you can get down which one's which, isn't tangent just divide him by him?
Yeah.
What happens to the 2's?
You cancel.
Well, that's nice. And don't they look the exact same, but one's a minus, one's a plus? So maybe it's not as much to memorize? And maybe cosine's happy because he gets to keep his cosine, so he's positive, and sine's kind of negative because he didn't get to keep his sine. I don't know. Make up a story. But there are ways of studying it. Yes, Joe?
I have a story like sine is not cosine for the first one, but the second one cosine is cosine.
Oh, okay, like negative, positive as in true, false. So sine is not cosine and cosine is cosine?
Yeah.
I like my positive, negative, happy, not happy thing better. But that's okay. That's fine. Use Joe's. Okay. So how do you use this? Well, what if we're supposed to do something like simplify? They would say something like simplify to a single power. They could say something like simplify to a single power of cosine. Simplify to a single power of cosine. Single power means he can't be squared. He can't be cubed. He can't be to the 4th power. You got to break them down to just be cosine to the 1st power. Well, what do you guys see? How can we use this formula? Okay. Joe's already seeing it's going to be this one, right? He's totally right. 1 plus cosine of 2. Yes. Excellent. So whatever the cosine squared is going to be put into that 2 times spot. So it could be of just x, it could be just theta, it could be just u, but it could be something extra, and we just have to put that in, all over 2. We would end up doing 1 plus cosine of 6x all over 2. Yeah. If the directions are simplified to a single power of cosine, we're like, yay, it's cosine to the 1st of 6x, but we don't care. Cosine to the 1st, yay, done. Well, they could throw something in there like equals 1, right? Like,
You on the test?
We're not on the test review yet, even though I'm giving you tons of hints. Okay. That's a harder problem. Maybe let's come back to that. Let's get to the last section of formulas. I'm going to pass out your 5-1, 5-2 quizzes. This is the last section of formulas you have to memorize. Remember, the other 2 sections of formulas we're going to look at a couple examples of tomorrow don't need to be memorized. Wouldn't be on the formula portion on. This is the last section of. Wait.
Oh.
Sines, not cosine. Or he's sad that his sign's not there. Cosine isn't this basically the last power reducing formula just with a square root? What? Go team. Now, is the tangent one a little bit harder? Yeah. The tangent one's a little bit harder because if you divide this one by this one, you cross off the 2's, you'd have to rationalize the denominator, so you'd have to multiply top and bottom by the square root of 1 plus cosine, which ends up getting a squared on the top and a squared. The squared on top is 1 minus is sine squared. Anyway, there's ways of going about that. Joe, they're plus or minuses, and here's the reason why. The struggle with half angles here must figure out plus or minus based on actual givens. The problem is you are going to have to figure out whether it's a plus or whether it's a minus based on what's actually given. So for instance, sine of 105, what quadrant is this in before I even start? Second quadrant. What's the sign of sine in the second quadrant? Right now, I know positive. I don't know much else, but I know positive. I wouldn't know much else unless I realized that 105 is actually 210 divided by 2. And 210 is in my unit circle. When you hear your name, come on up. Alfredo, Priscilla, Harana, Emma. Emma. That's so funny. Joe. Jason. Sorry, this Joe. Lauren is. I'm going to steal her correction paper. Thank you, Jason, for getting that. Joe Hudson. Ariman. Tyler. Chris. Smith, sorry. Matthew. Selma. Sam. Wesley. And Chris Massey. Okay, hold on to this quiz. Put it in your folder. Tomorrow at the very beginning of class, because we didn't get to check our evens, I'm going to actually give you guys just a little bit of time, like 2 minutes, 3 minutes in your groups, to look at each other's quizzes and get advice, ask any questions, okay? So very first thing when you come in tomorrow, grab out your corrections, and then we're going to look at them together, and maybe you can help each other, and I'll walk around the room. But then after that, we have to grade 5-4, okay? Maybe start on 5-5 tonight. See you guys later. Study your formulas above all else. If you're caught up on homework, study your formulas. We'll have some class time for 5-5. Bye, Joe. And for quiz corrections.